Okay, now that we've discussed how motion occurs, how to interpret motion, we're going to focus on the force of gravity because it's such a huge part of why objects move, not only on our planet, but in our entire universe. And so, as defined, what gravity is, it's a field that attracts a body towards the center of the earth or towards any other physical body having mass. So that's how we can interpret gravity on our planet. And this field of gravity is invisible, okay? We can't see it, but it's affecting the motion that occurs on our planet constantly. All right, and I put this apple tree there because that's the most famous example of Newton, having the realization that there is, something invisible, affecting the way that objects move. Okay, that's how he thought about it. All right, he not invented gravity. I know, which a lot of you like to say. And what this visual represents is essentially that is exactly what's happening to us right now. Our Earth has such a large mass that it's constantly pulling us towards the center, which is a good thing because otherwise we would be floating up into space. And so there's always this attraction between objects that have any mass. Now, something that happens a lot, a very common misconception, is the interchanging of the terms mass and weight. Okay, and they're different. Mass refers to how many atoms are in an object, and we use grams to determine mass. Now, your weight is that mass, however, times the force of gravity on the planet that you're currently on, which typically is Earth. And so the force of gravity for Earth is about 9.81. And so you take your mass, multiply it times that force of gravity, that determines your weight. And that's why you're seeing here, if you were to ever travel to the moon, your mass would always stay the same, but your weight would be different. If you've ever seen videos of astronauts exploring the moon, it does kind of look like they're bouncing. And the reason for that being is there's less gravitational force between them and the object that they're on, the moon. And so it has less of a pull, which allows them to move a little bit more freely. And so there's two basic variables that determine the strength of gravity. And so gravity is acting between all objects, but if the mass of those objects increase, then the force of gravity increases. Distance wise, if distance increases, gravity decreases. All right, so it's that inversely proportional concept that we've been discussing with distance. All right, so if objects are farther away, that force of gravity decreases. And so you can use a data table like this to determine which combination would result in the strongest force of gravity. So if we look over here, it's looking like this one, gravitational force, this combination leads us to have the strongest force. Because if you look at this one has more mass, this combination, than the ones above it. So then why does it have more gravitational force than this combination? If we take a look over here with distance, there's less distance between these two than there is between these two objects. And that combination of more mass and less distance results in the strongest force of gravity. It makes sense, over here that these ones are less because there's less mass. Also over here, there's more distance. So take this time to pause, maybe copy this down and, looking at these combinations, how you could determine, different other combinations and why some have stronger forces of gravity than others. Now, we also see how gravity can influence motion of objects in the solar system as well. And so the sun is enormous. So much larger than the Earth. It has an insane force of gravity, and it is what keeps us, revolving around it each year. And so the Earth wants to move forward like this. However, the pull of gravity between these two objects is keeping it in this path of the orbit. This visual here of an asteroid, all right, um, what happens is if an asteroid is traveling on a path, it's going to want to keep going this way. But as it gets closer, that distance decreases between them, between a planet. It's going to change its velocity. It's going to speed up as it gets closer to the planet and also change its direction. But as it moves farther away, the Earth didn't have enough gravity to keep it in an orbit. It'll then go on its desired path. And so gravity not, only influences motion in the solar system, but on our planet as well. Anytime you jump, you come down. In sports, the way that we handle things is very, very much influenced by that force of gravity.